Okay, let's give you guys some more practice. So again, similar to the previous video, we're on Mars. Gravity on Mars is still this, but this time we're going to shoot the cannonball at 42 meters per second at an angle of 55 degrees. Find out the exact position of the cannonball after 15 seconds. So find out the height of the cannonball after 15 seconds, and also find out this distance of the cannonball after 15 seconds. Okay, so basically find out the exact location of the cannonball after 15 seconds. So press pause and have a go. But let me just give you a quick tip here. Find out the maximum height here, and then work out how long it free fall for. Basically, it's going to free fall after the maximum height. So find out the free falling distance, and then get the maximum height. Take away this distance here. Then that will give you this height of the cannonball after 15 seconds. And then once you've got that, then imagine you and your dad sitting in a car traveling at whatever speed it is for 15 seconds. So how far would the car have traveled after 15 seconds? So that would represent the distance from here to here. Okay, well, do whatever you have to do. Press pause and have a go. Okay, so first thing we should do, hang on, is to break up our. Hang on, let me move this across a bit. Hang on. The first thing to do is to break up the diagonal speed here to its vertical and horizontal components. So here the vertical components will be this, horizontal will be this, and then jump to your velocity time graph, which would be this. So this here is our initial vertical velocity here. So this point here will be 42 sine 55. Okay, and the gradient here is given by this. Well, anyway, the equation for this line is given by this here. And then you want to know T max. Remember, T max is the time it takes to get to its maximum height. So find out the maximum height first, and then later work out this distance. So at the moment we are just aiming for the time. We are aiming for we are aiming to work out the maximum height, but we need to know the time to get to the maximum height first. So the time it takes to get to maximum height is given by well, it's represented at this point here. So you put 0 into the v here to work out the time at maximum height. So put 0 into the v here, and then try and work out t here. Okay, and then blah blah blah, and then you will get to t equals this. So this here represents the time it takes to get to the maximum height. So if you look at this here, this distance here, okay, is represented by this. Okay, and then well, now that we've got the time it takes to get to the maximum height, we can work out the area here. This area represents the actual height. So that area here represents this height here, the maximum height. Okay, so to work out the area here, we would need this height here, which is remember, this point here is 42 sine 55, and this length here, the time here, is given by this. So basically, you would get this time here times the height here, and then cut in half because it's a triangle. So basically, get this times this thing here, and then divided by 2. So the actual maximum height is given by this. This here times the time it takes to get to the maximum height, and then divide the whole lot by 2. Okay, so yeah. So remember, this bit here is this height here, and then this bit here is this bit here, and then we got to divide it by 2. Okay. At the moment, it looks quite ugly. So let's just concentrate on this bit. Let's tidy this bit up. So you are getting this multiplying a fraction, so it's going to get multiplied to the top. The thing is, at the moment, it's this times this, and then the whole thing gets multiplied to the top. So basically, you're timesing this thing here. So basically, you can get this times it. So 42 times with the 42, and this thing here times with this thing here. So that will give you, well, 42 times 42 would be this, okay, and then the sine, this thing here times this thing here will be sine squared 55, okay, and then but basically this whole thing here, okay, is this whole thing here, okay. This here is just a sine squared. This squared thing here is just a way of us saying sine 55 times by itself. It's just a way we write it. We'd stick the squared in here, but don't write it as this sine 55 squared, because here you would square the angle and then you would sine it. Well, this is just a way of us writing it. Okay. So hang on. Let me just go back one step here. So at the moment, our maximum height is given by this. But the thing is, we've got a fraction within a fraction. It looks really ugly. So concentrate on tidying this bit up. Yeah. So basically, it's this thing multiplying to the top. So that becomes this thing here. Okay. But don't forget this 3.71 here is here. Okay. So hang on. So this whole thing here is this whole thing here. Okay. And now rather than having a fraction within a fraction, visualize it like this. So that bubble here, this bubble here, okay, this bubble here is this thing here, but visualize the divide by 2 as this. And now when you divide a fraction, it gets multiplied to the bottom. So it then becomes this. Okay, this is getting it a bit neater. Then you would jump to your calculator, and it turns out that the maximum height is given by this. Okay, so far our diagram would look like this. The maximum height is this bit here. We've just worked this out. Okay, that's this thing here. So the maximum height is hang on. So the maximum height is this now. Now, if you look at our velocity time graph, the time it takes for us to get to maximum height is given by this. Well, you would jump to your calculator and convert it into a decimal. So it takes us 9.27 seconds to get from here to here. Now, if it takes us 9.2 seconds to get to here, then this bit here would be 15. Take away the time it takes to get to maximum height. So basically, we want to know the we want to know the distance of the free fall now. So the cannonball is going to get to its maximum height, and then it's going to free fall down here. So get 15. So now get 15. Take away this thing here. Take away the time it gets to the maximum height. So this 5.73 represents the time it will free fall for. So from here, it will free fall for 5.73 seconds. Okay, it will free fall for that amount. So the cannonball will get to its maximum height, and it will free fall for 5.73 seconds. The thing is, what will be the distance after a free fall of 5.73 seconds? Then you would jump to your hang on, let me just move it across. Hang on, sorry. Bear with me. Yeah, hang on. I'm just going to move it across so that you can see. Hang on. So now that we know that it takes us now that we know it takes us 5.73 to free fall. So remember, we are free falling for 5.73 seconds here. Okay, we want to know the distance here basically. Okay, so So now jump to this free falling formula here. You should know this but inside your head by now. So basically, put the time. Remember this. We did this ages ago. So this diagram should come to mind. So when something's free falling for 5.73 seconds, it would have covered this distance here. So we work out the age. So you put the 5.73 into this t here. So this is 5.73. Square it, times the gravity, and then divide it by 2. And then it would give us this. So what it's saying is that after free falling for 5.73 seconds, we would have covered a distance of 60.91. So what that means is in our diagram here, this distance here is what is it? Is well, hang on. That after reaching our maximum height and falling for 5.73 seconds, the distance covered would be 60.91. That's this number here. Okay, so that number here represents this distance here from the maximum height to here. So now we just need to get the maximum height, take away this bit here. That will give us the actual height of the cannonball. Okay, so that would be this. Take away this. That will give us this. So the height of the cannonball is given by this bit here. So this height here, hang on, this height here is given by this. Now you still need to know this distance here. Well, imagine you and your dad sitting in a car here, driving at 42. Driving it at 42. 42 cos 55 meters per second in this direction. And don't forget, you're traveling for 15 seconds because it takes 15 seconds for the cannonball to get to here. So you would just get this bit here times with the 15 seconds. So basically, get this times with the 15, and then it would give us this, and then jump to your calculator, and it would give us this. So it would be roughly 361 meters. So this distance here is roughly 361 meters. Okay, so we've just worked out the height and the distance here after 15 seconds. Okay.